So we've spent a lot of time doing factoring and graphing quadratics, and we're still going to be dealing with quadratics. Remember, that's a parabola. But today what we're going to be focusing on is quadratics, solving quadratics by using square roots. But before we can actually get to the solving portion, we're just going to deal with square roots or with radicals and their basic properties and simplifying them and so on, and then we'll get to this actual solving. So this will be two separate sections that we're going to do, focusing on just the radicals and their properties first. So this is section 4.5. What we're going to start with is something really basic. You might even remember doing this at one point. If I give you the equation x squared equals 4, to solve for that, all you would have to do is take the square root of both sides, because remember, if you have something squared, the square root undoes it. And when you take the square root of both sides, what you get is that x is equal to 2 or negative 2. Remember, if you have a square root of a number, you have a positive and negative answer. Okay, so that's going to be really important as we get into the solving, that you write both answers down, otherwise you're missing a whole separate solution. Okay, so two separate answers, one positive, one negative. Alright, so let's look at some basic properties. Here I have a simple radical, and I'm just going to label a few things for you here. Just in general, this whole number as a whole, that's called a radical. So all of it together. Okay, but then we have a couple parts that are inside of that radical. The first one is the radical sign. Okay, hopefully that's really obvious. And then whatever is underneath the radical sign, that's called your radicand. Okay, so make sure you write those terminology down. The radicand is whatever is underneath, the radical is the whole thing, and then your radical sign is just that symbol that we draw. So if you ever hear me refer to any of those three different things, make sure that you know what each of those means so that you understand what we're talking about in class. Alright, a few basic properties that we're going to work with. These are going to be really helpful as we get into more complicated problems. The first one, if a and b are larger than 0, because right now we don't want to have any negative numbers underneath the square root sign. The first one is the product property. If you have the radical sign with our radicand that is a times b, we can actually separate those into the square root of a times the square root of b. And sometimes that's really helpful when we want to simplify something, is just break it up into two separate numbers, and then sometimes it will reduce a lot easier. Our other property, since we're dealing with the product, is with the quotient. Remember, quotient is division. So if we have this square root of a divided by b, that is the same thing as the square root of a divided by the square root of b. Like I said, this is going to be helpful when we have to simplify some solution or some problems later. So here's an example. For this one, this first example that I've got, I have the square root of 40. Well, you could easily type that into your calculator and try to figure out what the square root of 40 is as a decimal, but from now on I do not want any decimals. I want exact values, which means it has to have a square root in it, unless it simplifies. So in this one, we want to think of a number that's a perfect square, okay, and then whatever the other number is. So in this case, 4 times 10. Well, when I break 4 and 10 up, the square root of 4 and the square root of 10, the square root of 4 we know is 2, and the square root of 10 does not reduce, so our answer would just be 2 times the square root of 10. My suggestion for these is to always pick the highest perfect square that goes into it evenly. So 4 is the highest perfect square, so we just took 4 times 10. So this is going to be where you need to really remember what Mr. Pace taught you about your perfect squares. I know he had you quiz or have to say those really fast, and that's going to come in handy when we're doing this section. The same thing applies for the quotient property. For this example, I have the square root of 3 over 4. Well, when I simplify that, I break them into two separate parts, the square root of 3 over the square root of 4, and you can reduce it. This reduces to the square root of 3 over 2, because the square root of 4 is just 2. Okay, so even though they don't necessarily look like they're simpler, we've reduced it as much as possible, just like you would reduce a fraction. Alright, here's some basic properties as well, using those properties. If we want to simplify, it says simplified if the radicand has no perfect square factor other than 1. So that's a good way to check if it's simplified all the way. So if your number has no other perfect square in it, you probably can't reduce it anymore. Okay, you also cannot have a radical in the denominator, and we'll work on solving for those. Okay, so here's some like basic examples. All right, example 1. Here we have the square root of 500. Well, obviously this can be reduced, so we need to figure out what perfect square goes into 500. And hopefully, right away, you could think of 105, because 100 is a perfect square. So when we reduce this, or first we break it up, the square root of 100 times the square root of 5, and hopefully you all remember the square root of 100 is 10, so we would get 10 times the square root of 5, because 5 can't reduce anymore. There's no perfect squares that go into 5. All right, this next example gives us 3 times the square root of 12 and then times the square root of 6. So we're kind of incorporating a couple different things here. So for this one, what I would do is actually do the opposite of these properties. What I would do is combine the 12 and the 6 into one square root. So that's going to get you 3 times the square root of 72. And then go ahead and find your highest square root, or highest perfect square. This one may not be as obvious. And this one, the highest perfect square is 36, and if you don't know that, you might have to do a little bit of work on your piece of paper. Remember, don't use your calculator for this. Okay, so when we reduce this, we get 3 times 6 times the square root of 2, and of course 3 times 6, that gets us 18. So all of this reduced is 18 times the square root of 2. Okay, and if you're going through these, hopefully it's kind of ringing a bell with those perfect squares. That's really going to help make sure that you're getting everything taken care of. All right, and here is another example. This one's a division one. We have square root of 25 over the square root of 9. Well, if you break that into your two separate square roots, this one's really nice because everything reduces. The square root of 25 is 5, and the square root of 9 is 3. There's your answer. Okay, so very short problem, just reducing your square roots. I want you guys to go ahead and try these on your own. Please try them without me showing you the answers, because that's going to help you get some practice, and that way if you really are stuck, you can make sure you ask me. So press the pause button and try on your own. All right, what you should end up getting for number 1 is the square root of 9 over the square root of 64. So what you want for that one would be 3 over 8. That one reduces. And then for the next problem, we have the square root of 98. Well, the highest perfect square that goes into 98 would be what? And you may have tried a couple different things, but for this one, your highest perfect square, and I'm just double checking here with mine, is going to be 49. So when you get this one, you're going to break it up into 49 and 2. So you're going to get 7 times the square root of 2. Okay, and then the last one, just like the other example that we did together, I would multiply 8 times 28, and you get 224. Okay, well for this one, the square root of 224, you're going to have to find another perfect square. So you might have to do a couple different trial and error to see what you get. I think I get this, the highest perfect square is 16, so you'd get 4 times the square root of 14. Okay. If you get something different, make sure that you're asking. All right. We're going to go ahead and stop there. I really want to make sure we're good at simplifying these, and then we will continue with rationalizing the denominator in the next video. Thanks for listening.